Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is Spencer Lamb. He's from Kao Data. He is the VP of Sales and Marketing at the company. Spencer, welcome to the show today.
Thank you, Rich, for having me.
Well, thanks for coming on once again. But let's start at the beginning, Spencer. Who is Kao Data and who do you help?
Okay, Kao Data is a data center provider just north of London. We develop and operate state-of-the-art and advanced data centers, predominantly for the high-performance computing community. And the way we've done that is by looking at the hyperscaler global footprint of their data center capacity and adopting those principles with, in effect, like the Open Compute project, and designing our data centers in such a way that it enables our customers to easily deploy their high density infrastructure in a simple and effective fashion. And that's been the core and basis of our principles and offering to the markets. Because of where we're located between central London and Cambridge. And in the UK, that's termed the Innovation Corridor. And over the years, many organizations have evolved to support research in many different ways. But over those years, a number of research institutions have grown up there. And in doing so, they've deployed large HPC installations and clusters. And what we're trying to achieve with our data center is to create a colocation environment where they can install those HPC infrastructures without having to worry about bringing huge amounts of power into their campuses to support those large clusters.
Well, great, Spencer. So you're within this UK Innovation Corridor. Can you tell me more about the organizations that are part of that?
The UK Innovation Corridor was germinated by Cambridge University many years ago. And I guess in the advent of HPC being a meaningful part of research over those last 30 years, they were most likely the original adopter of it within the innovation corridor. But as that's evolved, you've had two kind of parallel work streams, if you like. You've had the research institutions who are publicly funded, so the likes of the Wellcome Trust, the European Bioinformatics Institute, and then in parallel, Cambridge itself has been investing in startups from students who've left Cambridge University with some great ideas, and Cambridge initially has invested in those organizations, and then over the years, those organizations have grown and grown. And then overlaying that, or underpinning it, you've had the pharmaceutical companies coming in and then deploying their own staff within that environment, and also deploying their own HPC clusters as well to interconnect with what's going on within the research community. So a huge ecosystem has been generated predominantly by Cambridge initially, but over the years, more and more research institutions and private businesses have come into play. And then at the south side of the corridor, in central London, you have the universities, UCL, King's College London, Queen Mary University. You have the Francis Crick Institute, and then down the road from them, you have all the fintechs that have been flourishing over the last few years, who again have adopted HPC and probably been the most recent adopters of that technology. And we see that being more and more prolific with the quantitative hedge funds. And now they're adopting the GPU technology, and they're all looking for somewhere to house this infrastructure. So our solution, if you like, has been to design a data center for those high-powered systems and ensure that they can locate those high-powered systems in an environment that's simple, effective, and straightforward.
Well, terrific. But how are you differentiating? That must be a very busy geography there with data centers. How do you stand from the crowd?
Traditionally, the data centers in the UK and Europe and globally really kind of the base design is predicated on a single IT rack deploying 5 kilowatts of IT load. That is no longer sufficient. Certainly, I don't see that as being sufficient in the future. When you talk to anyone in the HPC community, that would be laughable to them. That's 2 or 3 servers. So our design has been predicated on deploying upwards of 10 as a base design, a standard design of 30 kilowatts a rack. And then beyond that, looking at direct cooled solutions, so liquid to the chip. For many years now in the colocation world, we've heard about this technology, but no one's seen it within a colocation data center. I'm now seeing demand for that more and more from the community that we're talking to.
Well, great, Spencer. I guess how do you see the UK data center market? How do you see that evolving? especially for HPC and AI?
I see it evolving quickly and vastly over the coming months and years. I think we're in a really interesting time in the data center market, in the more mature data center markets, if you like. We've seen huge adoption of colocation from the hyperscalers providing their cloud services to in-country end users and government institutions. Now with exascale being at the forefront of every HPC user's mind. To achieve those volumes of compute, you need a large power infrastructure to achieve it. And those organizations are unable to go and buy some land, bring some power online, and build a building for that environment. That would take them 3 years and a lot of capex to achieve it. So I see them now turning their heads to the colocation providers to provide that service to them. But what the colocation providers need to appreciate, that it's a very different model from standard colocation capacity. This is genuine high density. This is genuine huge HPC clusters with InfiniBand interconnect. They have to be these racks have to be adjacent and contiguous to one another. And therefore, the data center needs to be designed from the ground up in that fashion. Otherwise, it won't work.
Right, because the needs of that HPC market, they want that low latency, and you can't fake that, can you? Right.
Yeah, and that's another point to raise, because this is like HPC Edge, if you like. In the past, it's not in the past, it's current today, the data sets that are moving around of significant size and the terabytes in size. So you can't be having a production where all the laboratory work's going on and all the production's happening in one geography, and then try and send that across to your HPC cluster hundreds of kilometers away. What we're doing with our facility, because it's in such close proximity to the research community in the innovation corridor, we've been working with the local connectivity providers to enable us to deliver dark fiber connections and 100 gig wavelengths from our data center to where that information is being produced and where that data is being produced and where that research is happening. And that's absolutely crucial. It will not work otherwise. And what that means is they can send terabytes of data down those pipes, and it will happen quickly, but more importantly, it will be cost effective.
Right. So, Spencer, this is exciting to hear about this HPC resource in the UK. And I want to thank you once again for coming on the show today.
Well, it's my pleasure, Rich. Thank you very much. Great to meet you too.
Well, thank you again. All right, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.